All right, so this video is the video to graph cosine of theta, to graph the parent function. If you notice, it's the exact same table, except now instead of it saying sine of theta, it says cosine of theta. I'm going to be skipping a good amount of steps here, going a little bit quicker, so go back to the video for graphing sine, the parent function of sine, and it'll be basically using the same thing. I'm trying to show you here that the table, I'm sorry, not the table, the XY axis is the same, right? You still have 0 degrees, then 90, then 180, then 270, and then 360 degrees. So that's what I'm going to do right now. I'm going to go ahead and change these radians into degrees just because it's a little bit easier for us in the beginning. If you want to work with radians, you can. It's just going to be a whole trying to memorize it, or just trying to, I mean, you work with it so much that eventually you'll get the hang of it and you won't even have to convert from radians into degrees. But here, I went ahead, did the same thing I did before with the sine table. So I changed them to degrees. One thing I need you to really understand here is what that y right there means. This y is not the rule for cosine, right? We're talking about trig ratios. This y is just a name for the graph that I eventually am going to draw right here in this xy axis. So I could have easily, just like before, changed it to f of theta, or changed it to, I mean, it's really weird, right? We say y, but you go ahead and you just understand that that's the name of the graph eventually. You can use like different random letters, G and stuff, but you wouldn't really use it just like that, like G. You would either write like G of theta and different notation. So right now we're gonna go ahead and ignore this part and just think about cosine of theta, right? What is the rule for it? And just from your notes in class, your general knowledge of it, it's cosine of theta is equal to x over r, but we know r is equal to 1 based off of the xy axis we drew, which just means it's basically just the x value of the point. Though, if you remember from the sine video is the y value. So you're pretty much just going to go and just choose your x part of the point for every single point. We choose 0, 90, 180, and 270 because they're the easiest ones to work with in the beginning. Notice how I'm highlighting all the x values of every single point, because we just, remembered that the definition for cosine is x. So there you go, right? We start at 0 degrees, so that's 1. So that's going to be my first answer. So cosine of 0 degrees is going to be equal to 1. Wow, that was a really ugly one. All right, there you go, 1. So cosine of 0 degrees is equal to 1, and then we basically just go back to reference the xy axis. Cosine of 90 degrees is the 0, and then it's the -1, and then it's 1 again. Sorry, no, it's 0 and then 1 again. All right, it's just all about going back and looking at the xy axis that we always, reference. And so now we're just going to go ahead and plot them. If you notice, there's always patterns, right? The sign, it's 0, 0, 1, 0, -1, 0. This one is, now you start at 1. 1, 0, -1, 0, 1. So then after that, it would have been, 0 here, depending on which value you choose here, if you choose your appropriate value. So let's go ahead and basically all we're going to do is plot them now, the exact same way that we did before. So go ahead, pause the video if you want to, and plot them and see if you can plot them in the right place. And then, just create the curve, the nice curve. Be a little bit creative with it. Sometimes it's a graph that you've never seen before, and that's fine as long as you're following the rules of how to plot. So the first point is 0, 1, which, that means you stay here on the x-axis and you go up 1. The next point is pi over 2, 0, so that just means you stay there. You go out pi over 2, and then you stay there. You don't move up or down. And then it's 3 pi over and then it's pi at -1, and then it's 3 pi over 2 at 0, and then 2 pi at 1. If you notice, it looks very similar, a little bit to the sine one in that it's gonna be a little bit curvy. This one definitely like it's gonna look like a V. You have to be kind of careful with that. It can't have like it can't have corners. That has to do with continuity and you start talking about like inflection points, stuff that you don't need right now. Okay, that's not important. The only thing I would say is don't make it a V, right? Sort of like if you notice, right? Actually, yeah, I'm going to draw it right now. So if you notice, it sort of has that kind of shape. You know, yeah, no, this should be all the way at the top. This dot should be all the way at the top. So let me go ahead and just draw it one more time. There you go. So just imagine as this dot here is like the highest dot on this little like curve right here, right? And so if you notice, we go back to the whole 5 points thing, right? 1, 2, 3, 4, 5. We talked about this in the sine video that 5 points creates like the one cycle of cosine, right? It's okay if you don't know what that means. Like cycle and stuff like that is what's going to happen in the next video. But for right now, just understand it's 5 points is what creates, one entire repetitive cycle for cosine. So then here you see, right? Think of it like this. This point is technically, right, that point if we basically just keep drawing it, right? So then that point basically becomes the beginning of the new cycle that we're going to do. So what I like to do is I like to draw the points, right? The easiest ones, the ones that are like the zeros. If you notice, it basically skips the one where it's a 1 and a -1. So you see, skips this one, the 0, 1, skips this one because that's the -1, 0, skips this one, and then just like that. You just connect it. I go from left to right just because, it makes it a little bit easier to see that this here is the exact same as this over here as we go from left to right. Again, the arrows because, it always keeps going forever. Keep going forever because you can keep adding 360 over and over. That's why you have this arrow. For this arrow, it'll be you subtract 360 over and over and over and over and over. All right, so here you go, right? It looks way smoother than mine. All I'm going to do right now is put those arrows just so you can remember that it always goes on forever. We can decide to restrict the domain, basically restricting the x values or the theta values that we choose. And so, that's where we would get a graph like this one here, where we restrict and we only care about like a little section at a time. So that right there is the graph for the parent function of cosine of theta. Very similar to the sine. Remember, the sine actually starts at 0 and then it goes up to 1 and it comes down, crosses 0, goes down to -1, and then goes to 0 again. So be very careful. They're really easy to confuse. For me, the way I always try to like remember is that the cosine, right? It always starts sort of like at a number if we keep it on the y-axis, right? It starts at a number as opposed to sine that starts technically like at our 0. You'll get more info and more details in the next video, the characteristics of trigonometric graphs. So there you go.